Hello, guys. I'm going to do two more questions in this one clip. So please follow me. Have your paper pencil ready? And this question is there's two limits we're working with. First one is x approaching positive infinity. The second one is x approaching negative infinity. So let's look at the first one. Okay. On the first one, we can see as x approaching infinity, right? So I'm going to put the analysis part or my scratch paper on the side. This is the kind of, I want your work to be the part of work you turn in and the part of work you're going to do on scratch paper. On the scratch paper, I'll be thinking, as x approaching infinity, the numerator, 2 times x which approaching infinity, x squared is going to be even larger, and 2x squared plus 1 is going to be large, and taking square root is still going to be infinity. So we got an infinity over infinity. Infinity over infinity, we know, does not equals infinity, does not equals to 1, right? It is an uncertain form, okay? It's an indeterminate form. It's called indeterminate form. Indeterminate. Okay, it's an indeterminate form. We're gonna learn this in the future chapters. We don't know what it equals to. It could equal to a constant. It could equal to infinity. It could be any number you want. So we cannot apply limit law, right? You cannot apply limit law. So what can we do? Well, we have some techniques we can use, right? So we're going to start out using the technique. So the technique, as we all know, right, is going to be the top divided by x, right? We basically assess the highest limit. The highest limit is x, right? X to the power 1, right? The denominator is x to the raised to the power 1. The top inside the square root, the power is 2. But when you take the square root, the power becomes 1. So x to the power 1, that degree is proper. Okay, and the top has a degree 1, the bottom has a degree 1. In the denominator is pretty straightforward. Okay, the denominator is pretty straightforward because I'm just taking x dividing into 3 over x. So I'm getting 3 minus, 5 over x, right? And each has limits, 1x approaching infinity. But the top, we want to take the x inside the square root. So x is going to turn into x squared. But it is not that simple because we know there's a following relationship, right? What square root of x squared? And of course we know this is equals to the absolute value of x. And as x approach, if x is positive, right? If x is positive versus x is negative, it's different. If x is positive, right? If x is greater than or equal to 0, the square root of x squared equals to absolute value of x is the same as x. If x is negative, then it's equal to the opposite of x. In our situation, x is positive. Actually, when x approaching infinity, we can assume, in our case, x is positive. X is positive, then x, right, is the same as the square root of x. So this is what happens in our current situation. And now continue, right? Continue. What we're going to do, we're going to substitute x by square root of x squared, because in our situation, x is equal to the square root of x squared. And under the circumstances, we have square root over another square root, and we can put them under the same square root sign, like that. Okay, and now inside here, we can take the x squared to divide into each one, right? So we're gonna get 2 plus 1 over x squared. Okay, so now we have 4 limit and the square root, right? This, well, 2 and 3, when x approaching infinity, these are constant. By limit law, their limit will be the same as the constant. And these other ones, right? We have this other properties we learned before, which is as x approaching infinity, when x is approaching infinity, 1 over x raised to the power r is equals to 0, of course, provided r is positive. And in our case, right, in the first case, the r is 2. R is 2. So this, we apply this property. If x approaching infinity and this r is 1, right? So we can apply limit law. So next step, you can see we're going to apply the limit law. So we take limits individually. So we're going to take a limit, and the limit will go through the square root, because square root function is a continuous function. Do I need to put in front of the constant? It's optional, because the limit of a constant is always the same as the constant, so we don't have to do it. You can if you want to, okay, that's not a problem. Okay, so it's optional. And the next step, is we're going to just, this is going to be 2, right? And that's going to be 0, and that's going to be 3, and that's going to be 0. So in the end, we get root 2 over 3. Okay, so that's the first question. Second question, you see that the two questions, the difference is between x approaching positive infinity versus x approaching negative infinity. Okay, so everything being the same, okay, and the first step is the same. First step is the same, right? And on this part, on the next step, all right, on the denominator part is also the same, right here. The only difference is that when we divide it by x on the numerator, we want to substitute x by square root of x squared, so that we can put that square root for the numerator and denominator together, doing something we've done before. Oh, sorry, this is a negative infinity. Sorry, this is a negative infinity. Okay. But in this case, because x is approaching negative infinity, right? X is approaching negative infinity. All right, so I'm going to bring this down here. Because x is approaching negative infinity, so we're going to use this branch. So x is approaching negative infinity, so x is negative. So x will be equal to negative of the square root of x squared. So at this moment, right? If you compare what we did now and what we did earlier, the difference is that before, okay, the substitution, right? I'm going to put it here because we kind of absorb that step, right? So this substitution in the first part, it's just it's substituting straight. And in this case, we're going to substitute it by negative root x squared. It's because in one case, x is positive, the other one case, x is negative. That's the only difference. That's the only difference. But you need to know when that substitution takes place. This is when the substitution takes place. And the rest, you can see we generate a negative sign. This negative sign can be placed in the front of the whole thing. And then this piece is exactly the same as that piece. So they're put under the same square root. And then continue, right? This next step, you're gonna get to over there. Same thing, right there. Okay? And now this piece still applies, right? That piece still applies. Okay, so let me put it under and put this over here. That's the reason everything in the bracket is for you to see as for my presentation purposes. It's optional. It's optional for you to write it down. Now we're going to apply limit law, and we take limit law. We apply limit law to each individual limit. Constant, we can just skip. Okay. And finally, we got this is going to be 0, and that's going to be 0. Okay. And approaching negative infinity is the same thing. It's the same thing. Okay. And of course, there are some other details to discuss here, actually, because if you take a root, even roots, odd roots, and that kind of discussion. So for now, I'm just still going to use the positive infinity. Yeah, it should work. Okay, it should work. It's, regarding the sign, regarding the domain and things, when, cubic root, square root, yes, there are some distinctions, but assuming that R is, the domain is properly taken care of. So in the end, our answer is going to be square root of 2 over 3, but there's a negative sign in front of it. So you can see where the negative sign was introduced. It was at the point of substituting x before we introduce square root of x squared. You will see similar situations in some other homework questions and in my other lessons. Okay, so please follow me if you need to follow me again. Until you are, you're completely independent. You don't need to watch my lessons. You can do it all by yourself. So that's the goal. Thank you for watching. Thank you.